Sometimes we cannot simply add or subtract in order to eliminate one of the variables in our system. We have an example of that here. Notice the coefficient of the x terms. The top one is -2 and the bottom one is 7. They are not the same. For the y terms, the coefficient in the top equation is 15 and in the bottom it's -5. They are not the same. If this is the case, we're going to have to multiply one or both of the equations before we can add or subtract to eliminate a variable. To do this, we want to find the least common multiple of the coefficient of x or for the coefficient of y. For this equation, I'm going to concentrate on the y variables. I noticed that 15 and 5 have a common multiple of 3. If I will simply multiply the bottom equation by 3, I can make this -5y turn into a -15y. That will create a zero pair here and allow my y's to cancel. I am not multiplying the top equation by anything, so I am going to leave it as -2x plus 15y equals -32. I am going to multiply the bottom equation by 3. I have to multiply every term by 3. So 7x gets multiplied by the 3 to make 21x. -5y gets multiplied by the 3 to make -15y. And 17 gets multiplied by the 3 to make 51. I now see that the y's have the same coefficient. If I add these two equations together, I can create a zero pair for the y and eliminate the variable. -2x plus 21x gives me positive 19x. 15y plus -15y form a zero pair and cancel. -32 plus 51 gives me 19. When I solve the resulting equation, I will divide by 19 and find that x is equal to 1. Remember our third step was to substitute that variable into either of the original equations. Again, it doesn't matter which one you use. I'm going to use the bottom equation because there are less negatives in the bottom equation than the top one. Therefore, to me, the bottom equation is simpler. So 7 times my x value, which is 1, minus 5y will equal 17. 7 times 1 is 7, minus 5y equals 17. Subtract the 7, -5y is equal to 10. And when I divide by -5, I find that y is equal to -2. I now have the x value and the y value that correspond to the ordered pair where these two lines intersect. Therefore, my solution is the ordered pair where x is 1 and y is -2. I will now want to check that solution by plugging it into both equations to ensure that it is actually the solution for both of them. You try problem 1 and problem 2, then check your answer using the PowerPoint.